Hi everyone. The last time we are doing proofs, we started with proof by deduction. Deduction, it means it's direct proof. You look at the statement that you are given and immediately start from that statement to do your proof. Today we are going to look at proof by exhaustion. Proof by exhaustion, what we normally do here with this type of proof, you try to, if you are given a statement, for example, to prove that a statement is true, you try to break that statement into smaller bits, and then you try to prove those bits individually. So from there, you can immediately conclude that this type of proof is not suitable for very large problems. It might work for some problems, proof by exhaustion. It might not work for other problems. So let's see what we have here on the board. We are asked to prove that 53 is a prime number. Because if you are asked to prove that prime numbers are infinite numbers, that is, there are so many of them, and you're asked to prove that using exhaustion, proof by exhaustion, it's not just possible to do that, because we've got a large number of prime numbers which we don't even know the count. So you can't use proof by exhaustion to do that. So here we are given proof that 53 is a prime number. What is a prime number? Start with, what is a prime number? A prime number is any number that has only one and itself as factors. That's a prime number. That is the condition of a prime number. It has only number one, and itself as factors of the number. That's a prime number. What that means, if you have, like, 1 is not a prime number, prime number has to have two numbers, 1 and itself. So 1 is not a prime number. Is 2 a prime number? Yes, 2 is a prime number because it has two factors. 1, because number 1 is a factor of any number. You should know that. So it has 1 and itself. This is not a prime number. This is yes. What about 3? Is 3 a prime number? Yes, because only 1 and 3 can divide 3 without a remainder. Only 1 and 3 can divide 3 without a remainder. So it means it's only 1 and 3 are the factors of 3. And 4, is this a prime number? No. Why? Because 1 can divide 4 without a remainder. 2 can divide 4 without a remainder. And 4 can divide itself without a remainder. So you have 3 numbers here that are factors of 4. Therefore, 4 is not a prime number. Yeah? So now we know what a prime number is. So now we are asked to prove that 53 is a prime number by proof of exhaustion. What we just started here, the example I just showed you a few moments ago, is the same principle we use to prove that 53 is a prime number. We want to see the factors of 53. If it is only 2 factors or more, that's what we're trying to prove. If 53 has got more than 2 factors, then we know it's not a prime number. But if it has got only 2 factors, 1 and itself, then we can conveniently conclude that 53 is a prime number. So let's start. How do you go about it? We know 53, if you divide it by 2, you will get, let me use calculator. Yes. If you divide 53 by 2, 53 by 2, you get 26.5. Yeah? So it doesn't divide it evenly. You have a decimal point there. So let's try 3. 53 divided by 3. You get 17.6 repeats. Again, it's not a prime number. That's a decimal point. Let's try 4. That is being by proof by exhaustion. You split the problem into smaller cases and you try each case individually to see whether it works or not. And then after you've exhausted the numbers you need to look at, then you can then conclude your proof. 53 divided by 4, 13.25. Again, doesn't work. So let's try 5. 10.6. 53 divided by 5. 10.6. Again, that's a decimal point there. It doesn't work. 53 divided by 7. Again. 7.57. Doesn't work. 53 divided by 8. So, shall we do 53 divided by 8? Shall we do that? Shall we even do 53 divided by 7? Because we know 7 times 7 is 49. 53 divided by 8, we don't need to do that. Why? Because we tried 2. We got a number here with a decimal point. It doesn't work. It doesn't divide it evenly. We try 4. We got a decimal point here. 4 doesn't divide it evenly. And we know 4 and 2 are factors of 8. So if this don't work, 2 don't work, 4 doesn't work, 8 will not work. That's definite. It won't work. So we can't even go beyond this point. You can go beyond it, but it doesn't make sense to go beyond this point. Because now looking at the square root of 53, you know already the square of 8 is 64. The square of 53, the square of 7 is 49. So you have 49, 64, and our number is 53. So 53 lies between the square of 7 and the square of 8. So we need to stop there. We can't go further. So, what conclusion shall we make at this point? We can now conclude that there is no number between 1 and 53 that can divide 53 without a remainder. We have proven it. 2 cannot divide 53 evenly. There must be a remainder. 3, we've seen it here. There is a decimal point. 4, we've seen it as a decimal point. We'll keep on going. You can go 9, 10, 11, up to 53 if you want to, or up to 52. But what we are already seeing here, the factors of 8 are one of them 2 and 4. If 2 doesn't work and 4 doesn't work, so 8 is not definitely not going to work. Divide 53 evenly. And we now know that 53 lies between the square of 7 and 8. So if we cannot get our answer between these two numbers here, it means 53 is not a prime number. We are not able to get any number that can divide 53 without a remainder. We know 1 can. We just need a second number. We don't have it. So it means we know 1 can divide 53, and what other number that can divide 53 without a remainder? We cannot find it. We cannot find it here. So it means there is no other number that can divide 53 without a remainder except 1 and 53 itself. So the proof ends here. Thank you for watching.